All right, let's get this thing started. Right here, you see Ruka in the back. He don't know what's going on, but I do. This is Preston. I'm gonna rinse it off, right? I'm taking it off the initial solvent in the given container, and I'm gonna wash it off right here with some distilled water, right? Look at that. Wow. That's nice. Now, we're gonna calibrate this pH meter. That's the pH 7 buffer right there. On the right in green. And I'm gonna wait till it's reading it properly, and I'm gonna calibrate it. Boom, look at that. Time to wash it off. Round 2. Yeah, look at that. Wipe it off. Be nice and careful because it can break, you know, delicate. Gotta be nice. Now, thumbs up. That's how you know we're ready to go. I'm gonna measure pH 4 on the left. Wait till it's calibrated right. Calibrate it. Boom. Now we're gonna make sure, right? Thumbs up. Look at it. Wow. We're gonna make sure it's 4. We're gonna put it in there, make sure it's reading right. Wow, look at that. That's beautiful. Wow.
Hello, this is Ruka. These buffers we use are solutions that resist changes in pH. For example, in a buffer where a strong acid is added, the conjugate base component of the buffer reacts with hydrogen ions to form weak acids, thus preventing a drop in pH. A strong acid completely dissociates in water, leading to the release of all its protons or hydrogen ions. Compared to this, a weak acid partially dissociates, leaving a fraction of its protons behind, creating an equilibrium state. By adding a buffer to this acidic solution, the solution switches to minimizing the amount of protons lost.
Whoa, it's me. I'm back, and we're here to do the acetic dilutions right here, right? I'm taking the pH of the stock, it's 0.2 molar. We get a pH of 2.63. Look at that. Now, on the second dilution, we did this by adding 2.5 milliliters of the stock, and then diluting it up to 25 milliliters in that flask, and then we poured it in to get to 0.02. And here, I'm doing an example of dilation. Look at that. Wow, great form. I added 2.5 milliliters of the stock. All right, I'm no looker. Look at that. Now I'm adding water up to the fill line, which is 25 milliliters. Now here we go. Pour it in.
Hi, this is Justice Newton, and today I'll be going over experiment 3, which is preparing our buffer solution. So, at first we're going to mix 30 millimeters of our 0.2 stock solution of sodium hydroxide, which is our conjugate base, with 60 millimeters of our 0.2 stock solution of acetic acid, our weak base. So essentially what we're making is our buffer solution by adding the weak base plus the conjugate base, which in result just creates our buffer solution. And that's all you see.
Our results for exercise 3 resulted in a pH of 6.7 for tap water. The pH of tap water with a hydrochloric acid was 1.36. The buffer pH, which is NaOH, and acetic acid was 4.63, and the pH of our buffer and hydrochloric acid was 1.85.